And let us continue with our 2.3 limits review. Welcome back, everyone. What we're going to do is just continue on with the 2.3. Solve limits analytically and solve special limits. And you know what? Tag on a little bit of physics too, just for good measure. Quick little review of the, hour and a half, hour 40 minutes less than we did last time. Basic limits, when you take the limit of a constant, it just equals that constant. Limit of 3, no matter what x approaches, is 3. When you have the limit of a variable, you just plug that c, whenever you're approaching, into the variable. When you're raising that variable to a power, same thing, you plug that c in there, but then you solve. You have two special trigonometric limits. The squeeze theorem, the limit as x approaches 0 and only 0, sine x over x equals 1. The limit as x approaches 0 of 1 minus cos x over x equals 0 only when x is approaching 0. We also did some scalar multiplication. When you're multiplying something by that limit, inside the limit, you can just find the limit of that function, then multiply by the scale in the end. When you're multiplying, or you're adding or subtracting two different limits, you just find the answer of each limit and solve. You can multiply limits, find the answer of each limit, and then multiply them together, or multiply them in the beginning and solve that way. Same thing with division. You could divide the two limits, find the two limits, and then divide them, simplify. And power, you could do whatever you want in the limit, and then you raise to the power afterwards, and it gives you the answer. Now, pretty much what all this stuff means is when you're finding limits, all you're doing is you're plugging in your c for x. It's like substitution. So let's look at the first 4. All right. Limit as x approaches negative 8. Limit of negative 8 as x approaches 9. There's no x to plug in, so your answer is negative 8. The limit of 3x plus 1 as x approaches negative 2. You take the negative 2 and you plug it in for x. Negative 6 plus 1 is negative 5. Plug your 0 in for x. Now when we do that, get undefined. So typically we'd say, oh great, the limit does not exist. But we can use a what to figure out if our answer is correct. A table, we don't want to use undefined. Now, we don't want to use a table either because table was so 2.2, right? That was like a whole lesson ago. Now what we want to actually do is we want to factor. What can we factor out of all these? Well, we can factor an x out of the numerator, and then we can cancel out an x, leaving you with the limit as x approaches 0 of x minus 5 over 1, or the limit of x approaches 0 of x minus 5. Take that 0 and you plug it in. 0 minus 5 equals negative 5. Try to steer clear of the tables anytime you have the chance. Right here, number 4. All right, we just plug in the 1 right away. Spits out an answer of, what? Negative 2. All right, hopefully you got all 4 of those. This one might have been the only one that tricked you. All right, go on to number 5. Let's plug in 0. Undefined is our answer. So, you want to make tables? No, you try to reduce first. If you reduce this, you can take an x squared out of the numerator and denominator, leaving you with the limit of 3 as x approaches 0. Limit of a constant, no matter what x approaches, is always that limit. Your answer is 3. Got it? This is going to be a quick review. I can tell because you guys are experts at this. Problem number 6. I'm going to plug 4 in there. I get undefined. So we're going to reduce. You can take an x out of... No, you cannot. There's nothing, you would need x's in all 4 of these pieces. So you can't take anything out of anything. So what you have to do now is, since you can't plug in c and solve originally, since you can't factor and reduce and solve originally, and you get undefined for each one, now you make the table. Now you can make a quick table. I can tell you right now your answer is going to be D and E every time you get something like this. But let's just look to see why it is, okay? If you can't factor it and you still get undefined, your answer is going to be D and E. All right? This is why. Pick a number a little bit less than 4. How about 3.99? I just picked a number. You can pick whatever number less than. Now, as you do that, you plug this into this equation. Make sure the numerator and denominator are both normal parentheses. You get negative 5,787. If I pick a number that's like a tenth larger, I get 5,813. Notice one is a very big negative number, one is a very big positive number. Anytime you get something like this going on, it means this number is going really a lot negative when you get towards 4. This number is going really positive when you're getting towards 4. So that means 4 is going to be an asymptote. This one's probably going to be going to infinity. This one's probably going to negative infinity. All right? Because this one is shooting up as you get to 4, and this one's shooting down as you get to 4. Because they are not approaching the same number, that is where you get your DNA. Okay? Use the table to check your answer, not to solve. This tells you DNA. This shows you why. Problem number 7. Can we reduce anything from this? No, but watch out. When you put in 0, you should have got negative 7 over 3. Negative 3. Which is a positive 7/3. That's it. That's how easy that was. Problem number 8. Plug in 0, undefined. Let's try to reduce. X, 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 x. We can take 2 x's out of the bottom, 2 of the 3 out of the top, leaving us with 3x over 1, which is 3x. Plug your 0 in. 3 times 0 is 0 is your answer. Got it? Awesome. All right, let's go to the number 9, 10, 11, and 12. All right, number 9. You're plugging in negative 1. When you plug negative 1 in, 13, negative 1 minus 1, 13 over 0, undefined. There's nothing here to reduce, so now we have to just check our table. Answer is going to be D and E anyway, but a little number a little bit less is negative 1 and 100th. All right, you plug that in, you get negative 13,000. 0.99, 99 hundredths, you get 1300. So this one, as you're getting towards negative 1, you're going down to negative infinity. This one's going up to positive infinity. Obviously, they're never going to meet. There's a little unbounded behavior going on and an asymptote going down the middle. So this shows that your answer really is D and E. Right. Problem number 10. What can we do? Factor the numerator. Factors of negative 6 that add up to 1. X minus 2, x plus 3. Negative 2 times 3 is negative 6. 3 minus 2 is 1. And watch, look at this. Cancels out. Leaving you with the limit of x approaches 2 of x plus 3. You're going to plug your 2 in for x. 2 plus 3 is indeed 5. Number 11, factor the top and the bottom. Factors of negative 15 that add up to 2. 5 minus 3 is 2. 5 times negative 3 is negative 15. 2 times 5 is 10. 2 plus 5 is 7. I shouldn't tell you have to factor. All right, now, because if you typed in negative 5 in here, you got undefined right away, you know that the x plus 5 is going to be the problem. So that's what you should look for in both questions. That's like a quick little shortcut how to solve these. They cancel out, leaving you with x minus 3 over x plus 2. Now you're going to plug in your negative 5s and get negative 8 over negative 3, or 8 thirds. All right. Number 12. Cancel out the x squareds, right? No, you're not allowed to cancel out the x squareds. But you can just plug negative 3 in. If I plugged in negative 3, I'll show you that later, but if I pull the 5 out of the top, I'm left with x squared plus 3. I can cancel them out, and I get the limit of 5 as x approaches negative 3, and I get the answer of 5. If I plugged in, I didn't do it. You can actually just plug negative 3 in here. You get 5 times 9, which is 45 plus 15, which is 60. 60 over negative 3 squared is 9 plus 3, which is 12. 60 divided by 12 is also 5. Either way gives you 5 as an answer. Either way is okay to do. It's up to you. All right. 13 is the radical. When you use radicals, you have to use the conjugate. Conjugate is the same radical in front, but instead of a plus here, you're going to do a minus. Now watch what happens. FOIL. First, lose the radical. Outer is the minus. Inner is your plus. 2 times negative 2 is 4. Last. Cancel these out. 3 minus 4 is minus 1. Cancels out, leaving you with a 1 on top. So your answer reduces here to 1 over radical x plus 2, plus 3 minus 2. When you do your limit now, watch what happens. This is a little tricky. 1 over radical, 1 plus 3 is 4. Square root of 4 is 2. 2 minus 2 is 0. So your answer here is undefined. Even after you did the conjugate, your answer turns to 1 undefined. We've never seen that before. It does not exist. Do you know why that is? What is different than this question than the ones we did in the past? There's a plus here. If that was a minus, it'd be different, which I'm going to show you in a tad. This problem right here. X plus 5 over x plus squared plus minus 25, sorry. If I type in 5, obviously get undefined. Right? I would have got the undefined over there, didn't have enough space to write it. X plus 5 over x plus 5, x minus 5, cancels out, leaving you with a 1 as a placeholder in the numerator. 1 over x minus 5. 1 over 5 minus 5 is 1 over 0, which is undefined. All right? Now, Why is it DNA? Because even though I cancel this stuff out, I can't go any further canceling out. I get undefined. You can make the tables to check. Now watch this. Plus, plus. Say I take these two questions and I just change the signs right here. Do you think the answer is going to be the same? Why, let's check. Conjugate here would be plus 2. FOIL. First, lose the radical. Plus 2, minus 2, minus 4. The insides still cancel out, right? We're still the same. 3 minus 4. Now this is a little different. It's still minus 1, right? Now the only difference you have here is right here there's a plus. The x minus 1s cancel out, leaving you with the 1 as the placeholder. So this is because of this minus up here, left with a plus down here. And now watch what that does. When I go to plug in my 1 here, radical of 4 is 2. Now it's 1 over 2 plus 2 instead of minus 2. So your answer is 1/4. All right, so if this is a minus, this works. If that's a plus, not going to work. Look what happens here. X minus 5 is on top. Once again, undefined if I type 5 in. X minus 5 over x plus 5, x minus 5. Okay, now we're going to cancel out these two. So we're left with a 1 over x plus 5. When you type your 5 in here, because you're not subtracting it, you're adding it. 1 over 5 plus 5 is 1/10 is your answer. Okay, so just by making little mistakes, if you do that with negative signs, or writing the problem wrong, or not paying attention, or just like a little brain freeze for a second, you can mess up everything. Because notice the other ones didn't exist, and these exist, and they're just a slightly different problem. All right, let's try the next problem, which is number 1560, which is trig. All right, limit of cosine x over 3. Type in 0 into your equation. Make sure your calculator is in radian. Cosine 0 is 1, and it's over 3. Now, did you have to use this equation? No, because it wasn't 1 minus cos x over x, because there was no x on bottom. We didn't even need that equation. Let's see this. You need your interior to match your denominator. Multiply that by what? 3 over 3, very good. I heard you all the way from Point Pleasant. 3 times sine 3x over 3x. What does the sine 3x over 3x become? 1. So I pull out the 3. This becomes 1. That becomes 3. And 3 times 1 is? Anyone? 3. All right. Awesome. 17. Now we can use you. What do we pull out? Pull out a 2. 1 minus cosine x over x. This becomes 0 because it's approaching 0. 0 times 2 is 0. See how easy that is? Uh-oh. Tricky one. Let's change tan. 2. Sine over cosine, cosine over negative 3x. The cosines cancel out. So you're left here with, where we at? 2 sine over negative 3x. Now we can pull some stuff out. Sine x over x. That'll be isolated. And you have your 2 over negative 3 because they're both matching. You don't have to change anything. Sine x over x becomes 1. So you have negative 2/3 times 1. And your answer is negative 2 over 3. All right. Boom. Let's do the last 2. Plug 4 in here. You get undefined as an answer. Obviously, there's nothing you can really do. What's your answer? DNA. You want to prove it. Take a number a little bit less on the left, a little bit more on the right. See how this one's approaching negative infinity, this one's approaching positive infinity. Obviously, you can make a greater table if you don't see the patterns as much. So it's DNA. What do you think for 20? Cancel these out? No, this is why I put these on. Too many people think you could just cancel out x's if you have one on top and bottom. They would all need an x. So when I go to plug in a 0 here, 15 minus 0 is 0 is undefined. A little bit less, a little bit more. That's going towards negative infinity going down. This one's going towards positive infinity going up. Obviously, they're never going to meet. Another DNA. Once again, the tables are just to check your answers. The undefineds after you can't reduce it, after you can't multiply it by anything, after you can't change anything. That's DNA. Now, the reason you don't do this stuff is very simple. The table just shows that you didn't make a mistake and there wasn't something you could have done that you didn't do. All right. Last one. What we're going to do is we are going to do the physics problem. Then we're going to be done. Use the position function s of t equals negative 8t squared plus 450, which the height m of an object has fallen from a height of 450 meters. If a student drops a penny off a building, how fast will it be falling after 3 seconds? If the velocity t equals a is given by. All right, so here's the formula that we used before. A is not acceleration. A is just a specific time. So A is the time. Specific time happens to be 3 seconds. It's almost like an instantaneous time. T is just your variable, it's just t. To find S of A, you take your 3 and you're going to plug it into this equation. So negative 8 times 3 squared plus 450, negative 72 plus 450 is 378. Right? S of t is just that equation. Right? Easy. $378 minus the equation, negative 8t squared plus 450 over 3 minus, t. Drop the pet, I think. Distribute the negative signs. 378 minus and minus becomes a plus 8t squared minus 450 over 3 minus t. 378 minus 450 is negative 72. Now you're going to take the 3 and the t and you're going to flip their position and you're going to take an 8 out of the numerator. Now, perfect square. T plus 3, t minus 3. And if I take a minus out of here, this becomes a positive and this becomes a negative. Notice now they match up. Now I can cancel them out. So if I plug a t in here, it will not be undefined. That's the reason for this. 8 divided by a negative number. So it's 8 over negative 1, t plus 3. Negative 8 times t plus 3. I'm going to plug my 3 in here. Negative 8, 3 plus 3. Negative 8 times 6 is negative 48 meters per second. All right. Awesome, awesome, awesome. If a student drops a penny off the building, when will the penny hit the ground? The ground. S of t equals, do you remember? 0. So, set that equation equals 0. Add 8t squared both sides. 8t squared equals 450. Divide by 8. T squared equals 56.25. Take the square root of each side and t equals 7.5 seconds. All right, if I want to see the velocity of 7.5 seconds, I would just make my a equal to 7.5, and to find S of a, I would just plug in 7.5 into this equation. That would give me S of a. Plug it back into the equation we just did before, and then be done with it. All right. Made you a couple bonus problems. Ready for bonus? You like bonus problems? You never have too many problems. A little trickier. What can we take out of the top? An 11. 1 minus cosine x over x becomes 0. 0 minus 11 over 9 equals 0. Whoa! There's a fun one, right? Always good to throw in some trig problems. Sine x times sine x, because sine squared x is the same as sine x, the whole quantity squared. Each one of these sine x's, we're going to give an x to. So we're going to leave a 4x squared, an x for this one, and an x for this one. That way, because we're approaching 0, each one of these becomes 1. And then we can reduce this. 7x squared and x squared reduces out, right? And you're left with 7 over 4. Times 1, which is 7 over 4. Did you get that one? I think you got it. That one's not too bad. This one, you need the denominators to match, so we need this to be a 5x. So you multiply the top and the bottom by 5. Numerator, denominator. So you get negative 5 sine 5x over 7 times 5 is 35x. Turn this into a 5x, you multiply it by 7. Negative 5 over 7 sine 5x over 5x becomes a 1. Negative 5 over 7 times 1, negative 5 over 7. All right? Almost there. You want to do a couple more? Of course you do, or else you wouldn't be watching this. All right, here we go. We got a conjugate and we got a factor. What do we multiply that by? Radical x plus 9 plus 4 on both the top and the bottom. This becomes just an x plus 9. When you have plus 4 and minus 4 times this, it just cancels out. Negative 4 times 4 is 16. All right, you'll have with x minus 7 times that on the bottom. 9 minus 16 is minus 7. X minus 7 over the denominator. X minus 7 is cancel out, leaving with the 1 on the numerator. 1 over square root x plus 9 plus 4. We're going to now put it into our limit and plug the 7 in here. 7 plus 9 is 16. The square root of 16 is 4. 1 over 4 plus 4 is 1/8. Right? See? Hopefully I'm not going too fast, and if I am, pause. Factors of 36 that add up to this. Negative 9 and 4. And then this is, the square root of this is x plus 4, x minus 4. Reason this is negative 9 plus 4 is the negative 5. X plus 4's cancel out. Leave me with the x plus 9 over x plus 4 as limit is x approaching negative 4. You plug the negative and 4 in for both x's. This is a negative 8, not a 0, a negative 13 on top. Two negatives cancel out. 13 over 8 would be your final answer. Good. All right. Hopefully it's good, because that ends the limit review. So now you guys are experts at everything involving solving limits analytically, on top of the graphing and numerical stuff we did previously. All right, so good job with the limits, and good luck on your test.